Hello everyone, I'm Arnaud Pons, this is Gabriel Quennesson. We are from Michelin company, leader tire manufacturer, and we are part of Container as a Service platform entity, which is responsible to deliver Kubernetes platform to our internal project teams. And we are here to share with you how we scale cloud and on-prem infrastructure while cutting costs. So first, these are some metrics about Kubernetes footprint in Michelin. So we manage 62 clusters in 42 different locations, mainly due to deployment of cluster in each of our factory. And we have 450 business applications deployed on it with 36,000 pods.
So basically, our Kubernetes journey started back in 2018, and we've gone through several iterations of our platform since then. And back in 2023, we were using a vendor-based solution. And at this time, three streams of events converged. The first is that our vendor switched its strategy, and basically the products that we were using up until now will no longer be available. And it would force us into a cluster migration because the vendor will not provide us with a migration path from one product to this new product. The second is that Michelin matured on its open source strategy, and around this time, Michelin created its open source project office. And finally, Michelin always had an ambition to make IT specialists within the company thrive, and in this regard, opting for a make instead of buy strategy can go a long way. So at the end of 2023, we decided to rebuild our platform from the ground up, using only open source software, which Arnaud will now introduce you to.
So this is a global picture of the implemented solution based on open source projects. We can see in the middle of the picture the cluster API management cluster, which is used to manage workload clusters. In this management cluster, we have deployed several components. So the first one is ArgoCD to make GitOps at scale. We also use cluster API and providers to manage different infrastructure for workload cluster lifecycle. We have a Crossplane component to handle prerequisites for infrastructure and some add-ons deployed on these clusters. And we have a custom component, which is here to make the link between cluster API cluster object and ArgoCD cluster secret object format. On the bottom of the screen, we can see that we have several repositories. So the first one, there are Git repositories. The first one is used to store cluster inventories, cluster definitions, and their add-ons. We also have an ArgoCD configuration repository to store application sets. Application sets are ArgoCD objects used to dynamically create application based on cluster labels. And we have also some mchart repositories to store several add-ons, so Gatekeeper for policies, Cilium for CNI, and custom chart also. And finally, we have the workload cluster on several infrastructures, which will be built eventually and containing all the services necessary to be delivered to our internal project teams.
So the impact were mostly positive, as you can guess. The first we want to mention is that the engineering costs for our platform went down 44% year to year, and this is including the hybrid engineer we had on top of the already existing team. Another metric which shows for you is what we call the upgrade lead time. It could take us up to months to integrate the vendor solution back into our ecosystem, and it's now a matter of weeks to do the same work and we can use junior engineers to do so because the process is much more streamlined. And finally, while doing that, our Kubernetes footprint still grew about 100% while we were actually working on this project. And finally, and not the least of it, platform engagement. The engineer engagement is now much better because it's very much more interesting for us to work on open source software instead of vendor-based software. So basically, it's time for me to wrap it up. We have an article on the blog post up for you to read, and time for you to thank you for your attention.